Hello and welcome to lesson 1.5 for Math 111. Now, we've been dealing with or learning or spending a lot of time with factoring polynomials these last few lessons. In this lesson, we're going to dive into what some people call special products. So essentially, let me give you the lesson in like 10 seconds. These are just special ones that some people memorize. Okay? There. That's it. It's just there are formulas that people memorize. There are some I would encourage you to memorize, and some I would encourage you just to understand and not need to memorize. So the first one we'll look at is a perfect square trinomial. Okay, and this is one that some people really encourage you to memorize. I'm okay if you don't memorize this one because you know how to factor this one. Okay, so perfect square trinomial. We already can factor this without memorizing anything. Let me give you an example. What about like x squared plus 10x plus 25? You may not know this, but this is a perfect square trinomial. I say, hey, could you factor this? Without any of this lesson, you should say, yes, I can factor this. First off, is there a GCF? No. Well, let's move right on to our factoring skills. I know that these first terms are going to be x's. And you say, okay, well, what multiplies to 25 and adds to 10? Oh, positive 5 and positive 5. I did that really quickly, but I hope that you're getting faster at factoring as well. And so you're like, that was easy. I didn't need to memorize anything. And you say, oh, wait, I see why they say it's a perfect square. Because I could write this as x plus 5. There's two of them. I could write it as x plus 5 squared. It's a perfect squared trinomial. Okay. Um, but do you really need to memorize the pattern? Well, what is the pattern? I could factor it really quickly because I know the pattern, but I also could factor it really quickly because I know how to factor. What it is it's so notice it's plus 5. Well, 5 times 5 is 5 squared, and 5 plus 5 is 10. So if we call this some variable, let's just call it, what are we not using? I mean, let's call it m. That's maybe a bad choice, but I know that number m by looking here. This I know what the middle term and the last term is going to be. This term is going to be just double that, 2 times m. This last term is just going to be square that, m squared. So whatever the number is right here, I know what the middle term and the last term will be. Likewise, I can quickly go backwards from that by saying, oh, I know what this last term is going to be by whatever this is squared. If I see the pattern of whatever this number is, the square root of that, and it's doubled, oh, this is probably a perfect square. Let me make another one up on the spot for you to see what I'm talking about. We'll keep it simple. X squared plus, if we just pick a number, 3. 2 times 3 is 6x. 3 times 3, 3 squared is 9. That's a perfect squared trinomial. And I know the answer is x plus 3 squared, or x plus 3 times x plus 3. Well, how do I know that? Well, I look here and I say, hey, this is just 3 squared, isn't it? And this is just 3 times 2, or 2 times 3. Let's write it in the other order to be consistent with the formula. Oh, where'd my cursor go? Come back here, cursor. There it is. 2 times 3 times x, and this is just x squared. And so you start to see that there's this pattern where, oh, I have something squared, something times 2. No leading coefficient makes it easy. I could have a leading coefficient. That doesn't make it any harder. But it's a pretty simple pattern. You know how to factor without that, so I'm not worried about that one. Let's talk about ones that are a little more interesting. So another one that I think you should memorize is called a difference of squares. Difference, well, I'll write the whole word, difference of squares. Now, I loved math growing up, was good at it in high school and middle school, high school, and college and all that, decided to do it for a living, and I guess I'm pretty stupid because I never figured out, no one ever explained to me why these patterns are called a difference of squares. Let me give you a very simple one and see if you can figure it out and show how much smarter than me you are. They call these a difference of squares. What does a difference mean in mathematics? That means subtracting. So this is just saying a subtraction of squares. Well, we're usually lazy. This is really a subtraction of two perfect squares. X squared and 9 are perfect squares. This is a subtraction of squares. So, wow, that's all it is a subtraction of two perfect squares. I can factor that really easily because it always follows the same pattern. Well, it's a very simple pattern. The first term is x squared, and so x times x gives me x squared. The second term is 9. What is that? That's 3 squared. So 3 times 3 gives me 9. And then the only thing I have to worry about is the signs in these two binomials are always opposites. It doesn't matter which is which. This is the same as saying x minus 3 and x plus 3, but you should be able to factor these pretty quickly. Hopefully you also notice whenever we multiply things out, these are the ones where the middle term has disappeared. Because I would have negative 3x plus 3x, they disappear. And so these are really easy to factor really quickly. Now we could add more flavor to them or make them a little bit harder. Like I could do something like 4y squared minus 81. Those are a little bit more difficult, but that's a perfect square minus a perfect square. That is a difference of squares. So all I have to do is figure out what this is squared. Well, this is just 2y squared, and this is just 9 squared. So I know the first term is 2y and 2y. I know the second terms are 9 and 9, and it doesn't matter which is which, but one is plus and one is minus. Well, this is really simple then, right? Let's see. Maybe I'll throw another one at you for fun or for just some exploring. What if I gave you one like this? 12 minus 3x squared. You say, oh no, that's not a perfect square minus a perfect square. Those are not perfect squares. Well, what should we always look for first when factoring? GCFs. Let's see if there's a GCF that'll pull out of both of these terms. Oh yeah, 3 will factor out of both of these. So if I take a 3 out, what's 12 divided by 3? Or factoring a 3 out of 12 leaves me with a 4. If I factor a 3 out of this term, I'm left with x squared. Oh yeah, now it's a perfect square minus a perfect square. So this is not hard to factor at all. Let's see, what number squared gives you 4? 2. And what thing squared gives you x squared? X. And remember, one's always plus and one's always minus. So that's a really easy. That's also a really nice one to have memorized. Okay. Now, we only have 2 more in this lesson that I'd like to hop on. But what I'm going to do is I'm going to cover these last 2 at the same time together because they're very similar. They're actually kind of similar to this one. But let's go ahead and talk about it. These are when we're looking at perfect cubes. Well, not perfect. Well, yeah, perfect cubes within our problem. And we're going to look at the sum and the difference. Those are the 2 cases we're looking at of cubes. So we looked at squares. Now we're looking at cubes. Well, the first good question is, what's a cube? Well, what we mean is something to the 3rd power, like 2 to the 3rd power. That's 2 times 2 times 2, which is 8. So 8 is a perfect cube. So sum and difference. So what I'm looking at is when I have I'll write it this way. When I have a perfect cube plus a perfect cube, oops, I need a different number there, different variable. Or when I have a perfect cube minus a perfect cube. Okay, so when I have perfect cubes added or subtracted, both of them follow a pattern. Well, this is really, before I give you this pattern, really important to point out. Here, when I did this, it was only a difference of squares. Can you factor a sum of squares? So if I did x, that's a really sloppy x. Let me try again. X squared plus 9. Can you factor that? And the answer is no, you can't factor that. Sums of squares are not factorable. So don't even bother with that. Differences of squares are. But with cubes, let me get back on the right page, I can factor sums and differences. That's really neat. And they follow a pattern that's very similar. So what it is you just need to figure out what the first term is cubed and what the last term is cubed. And you just your first thing here is going to be a binomial of those two pieces added together, same sign. And then what you're going to have is a squared minus ab plus b squared. Okay, so if we have a cubed plus b cubed, a plus b, a squared minus ab plus b. Now, if it's a difference, it's very similar. The pattern's very similar, only some signs change. So what you have is a minus b, okay, a squared plus ab plus b squared. So here's some notes I kind of want you to write in. So notice no matter whether it's a sum or a difference of cubes, this last term is always a plus sign. Always a plus. Okay. Now, notice the first sign, plus or minus, just matches what you have. It's the same as what you had in the problem you're trying to factor. And then the second sign, plus or minus, is always the opposite of what you started with. So here's what I mean. So this is a to the third plus b to the third. So we're going to have, it was a plus, right? We're going to have a plus here. What's the opposite of plus? A subtraction, always a plus. Here's a subtraction. So what are we going to have here? A subtraction. So what's the opposite of that? Adding, always a plus. So that's the pattern. So let's actually see if we can use the pattern now. Okay, so I know that feels messy because it's in a formula. Let's actually try some examples to see if we can make it feel better. So x to the third minus 8. So if you look at this, it may be hard for you if you don't know your perfect cubes to know whether this is a difference of cubes or not. So I suggest you get a piece of paper to have with you all the time where you write your perfect squares and your perfect cubes down. Okay, so just like, we don't need 1, but 2, 3, 4, 5, 6, 7. And you could go as large, you could use a calculator to find these. So if I square that, that'll be 4, 9, 16, 25, 36, 49. I would go a good ways down. Perfect cubes now. 2 to the third is 8. 3 to the third is 27. 4 to the third, oh, we're getting pretty big. That's 64. 5 to the third is 125. It's useful to know these perfect cubes. And if you just have them written down on a little scratch sheet of paper that you keep with you, you don't have to hold these in your head. So look at this. This is a perfect cube. 8 is a perfect cube. X is a perfect cube. X to the third. Okay, so what is this to the third power? It's x to the third. What base to the third power gives you 8? Oh, it's 2. And so I can follow this pattern here, this formula to factor this. So I know that the first term is x. I'm going to keep the sign the same, subtraction, and the cube root of 8 is 2. So x minus 2. All right, now look what it is. It's the first term squared, so x squared. All right, now this second sign is always the opposite. So we have a subtraction, so it'll become a positive, and it's going to just be a times b. So both of these things, their cubed root are x times 2, so that's 2x. Okay, and this last one's always a plus, and it's always just b squared. What's our b term? It's a 2, so 2 squared is 4. Okay, and so there we go. We've factored it. Okay, and it's always that same pattern. The only thing people struggle with sometimes is figuring out what is this cubed and what is this cubed. This is, let me write some notes here. Like this is x to the third power. This is 2 to the third power. So figuring out your a and your b, or what things are being raised to the third power. Well, obviously it's x here, but 8 is 2 to the third power. Okay, so let's do one or two more examples. We did a subtraction. Let's do one that's a plus. Okay. We could add. I could make it a little bit harder. But give me a second. I want to wait a second before I make it too much harder. So that we could go with something like x to the third plus 27. 27 is a perfect cube. Okay, well, what is it cubed? 27 is the same thing as 3 to the third power. And so I should be able to factor this using my little pattern here. So the first term, the second term, what's being cubed is x and 3, and use the same sign. It's plus. We're doing a sum of cubes, so I have a sum, a plus here. Now, my first term is x, so I'm going to have x squared. Opposite sign, always opposite. Let's see, and then I'm just going to take a times b, or the two terms here. 3 times x, so 3x. Always a plus sign on the end, which will be this term squared. 3 squared is 9. And we factored it. So that's not too horrible. I think I only want to step up one more step of difficulty with these, okay? So I think that's pretty good. I think I have one more step of difficulty I'd like to go. I've given you very simple first terms, but what if I were to do something like this? 8x to the third power. I don't care if it's plus or minus. You can pay attention to the pattern. Let's do a minus for fun. And we'll go with 27 is big enough. 27. And so if you look back, these are both perfect cubes. I'm going to take the time to write something annoying. Maybe you might want to do this too, but 8x to the third power is the same thing as 2x to the third power minus 27 is the same thing as 3 to the third power, or cubed. So there's my first term, there's my second term for when I go to factor this thing. Okay? And so if we remember the pattern, it's the first term, same symbol, this happens to be a subtraction, minus the second term. It's the first term squared, opposite, so plus, opposite sign, a times b, always a plus, b squared. So that's the pattern, the formula. So if we follow it, this is the a, 2x, and this is the b, 3. So 2x and 3. So, okay, a minus b, so 2x minus 3. A squared, so 2x squared, that would be 4x squared. A times b, so 2x times 3, that's positive 6x. Plus, and now I have to square 3. 3 squared is 9. And so we factored it. So I'm going to go ahead and tell you, some people have this really quickly and easily. It's just a formula. It's just memorization. It's an online class, so you can have it written down in front of you. I can't do anything about that. But some people really struggle with this, so spend some time with this. Think about this. You know you can do the homeworks over and over and over and over again, but keep churning this until you feel cozy with it, okay? But that's all I have for you. Good luck on the homework, and email me if you need anything.